last week you heard from Frank about exploratory data analysis. It was the first part he introduced you to, just manipulating data. And prior to that, Duncan taught you how to import data. So now you should be comfortable with kind of opening up R, importing data, and then starting to work with it. So kind of take over from where he left off in data manipulation. So what we're going to do today is I'll sort of demonstrate a simple sort of data analysis pipeline, trying to put all of these steps together in terms of importing data, taking a look, cleaning it, and then if we have time, we can get to the basics of data visualization, which will be kind of explained in more detail in the next section. But if we have time, we will touch on it today. So without further ado, I will share my screen and do kind of interrupt me, raise your hand, type in the chat at any point, and then we can kind of answer questions as we go. Okay. So we are going to start with this slide. This slide shows kind of what a typical analysis pipeline might look like. Now, when I say the word pipeline, that's a very sort of data science-y word to use. It basically just means kind of a step-by-step procedure of how one might go about analyzing data. And these are, I've kind of broken it down into 7 main steps that we will cover. These are, some people take more steps than this, some people kind of collapse multiple steps into one, but this is kind of what I like to follow whenever I create something new. And this kind of ensures that you have clean code that's easy to share, other people can learn from it, that sort of thing. So it's a sort of step-by-step how you'd go about, and we'll go through all of these steps today. So I'll start from like a blank R document, and you're welcome to follow along if you are able. And if not, I do encourage you to try to start fresh and go through each of these 7 steps on your own. And so quickly, just to summarize what the steps are, the first step is always creating an informative header. You can think of your script like any other document that you create. So it's important to have your name, the date, just a quick title to give information about what you're writing. The second step is loading packages. So this is something we learned in, I believe, the 3rd module. So you want to load packages that are going to be useful for your code and for your analysis. Then you want to anchor your script. So Duncan introduced you to the here package and how that is useful for importing data and kind of making sure the file path where your code is saved is kind of relevant to or relative to where your data lives. So it just makes for easier organization. Then you actually import the data, which you also learned how to do with Duncan a couple of weeks ago. Then the 5th step is what I like to call a data snapshot. So often with data cleaning, you don't really know what to clean in your data at the beginning. You kind of it's a big, ugly Excel sheet. All of it looks disgusting, but just looking at a really big overview of your data is quite handy in recognizing some immediate things that you can clean. Then step 6 is the actual data cleaning. So this is what Frank started last week to show you how to clean your data and manipulate it. This, honestly, if you end up working as a data scientist, this ends up being like more than 80% of your job, because data, particularly health data, is very, very messy. So this ends up being kind of the main thing you do, and we'll kind of see what some typical steps you can take in data cleaning are. We'll see those today. And the last step, as I said, if we have time, we can touch on some data visualization, but kind of what you do when you have clean data is you either visualize it or you make some. And by visualize, I don't necessarily just mean graphs. You can make tables, you can summarize it, and actually start to answer some important research questions with it. So that's kind of what a typical procedure looks like. So before we start, I'll pause there to see if anyone has any questions. These can be questions related to this analysis pipeline or questions from last time. Just raise your hand or type in the chat. See any? Cool. You can start. I'll actually maybe share with you the data set we're working with. So that's what you see on my screen. It's a little bit different from the HIV data set that's online because I've purposely introduced some mistakes into it. Oh wait, I shared that with hosts and panelists. Let me share it with everyone. There we go. So there, I've shared it with you. You should be able to see it, but do let me know if you cannot see. It's HIV data _2.xlsx. And that is what we see on the screen right now. This is very similar to the data set you saw last time and the time before. This data set is of HIV patients. It has 6 columns. So you have a column for patient ID, age, gender, HIV status, CD4 count, and I think VL is viral load, but correct me if I'm wrong, Duncan. So that's
Yes,
kind of what.
that's viral load.
Sweet, thank you. This is what the data set looks like. I've purposely added some mistakes into it because, as I said, the data that you get is rarely ever as you expect it, particularly if you end up working with clinical records. A lot of these records, you know, even if there are electronic, people are manually inputting the data, and human error is always there. So it's quite possible that you have mistakes kind of in your data set, and you can see right away that there are a couple of mistakes here, but I won't dwell on it now. I'll actually show you how you can see them in R as well instead of looking at the actual data. This is the data set that we will be working with. I will close this. So for those of you who are following along, go ahead and open up a new R script. And as I said, the first step we're going to do is create an informative header. So, oh, welcome, Norbert. This is a fun one to jump into for the first time. Follow along if you can, but we definitely encourage you to check out the previous modules as well. But please do ask questions if anything is confusing. So this is going to be my header. I will say data analysis pipeline example. And I'll say this was modified. I'll say created by. I'll put my name. Then I usually have modified by. This is usually handy if you're working with other people on your code. So it's quite rare for you to be the only one using your analysis code. So you usually have information for who created the code and then who modified it, because sometimes it's not the same person. So that's kind of there's my informative header. If you want to be fancy, you can kind of create little lines over here. And if you remember, anything that comes after this little number sign or hashtag, this is a comment. This is not actually code that's going to be run. So the next step is we're going to load packages. So if you remember, there are several different ways you can load packages. My favorite one is Pacman pload, because this allows me to load many packages at the same time. If you prefer using install.packages and then library, that also works. But if you recall, pload will check if a package is installed. If it is not installed, it'll install it for me. And then finally, it'll load it for use. So all of that happens in one nice step. So I quite like using it. I'm going to load Rio for importing data. I'm going to load here for relative file paths. And use a package also called janitor for some data cleaning, and I'll tell you exactly what I grab from it. I'll use tidyverse also for data cleaning, and skimr for taking a data snapshot, and I'll show you that in a bit. And finally, stringr is always useful. I'm not sure if I'll use it, but it's a package used for textual data, so we can keep it there, but I don't know if we'll need it. And importantly, I can add more to this list. There's no, as far as I know, there's no limit. But I'll load these guys for now. So I'll go ahead and run that. That has run. We're okay. Next step is what I'm going to do. I'm going to anchor my code. This is, if you were here last time, this is a little trick I showed, which basically creates a relative file path that is anchored to where my code lives. That sounds confusing. I'll show you how it works. So right now you can see my coding document. I just opened a new R script. I didn't actually save it. So I'm going to go ahead and say File, Save. I'm going to save this R document to my data. I'll say data underscore analysis pipeline.r. Okay, so now you can see it's called data analysis pipeline.r. I'm going to anchor my code. So if I say here, : I am data analysis pipeline.r. This should, oh wait, hold on. Because I just saved it, it has not recognized where this is. So it's going to prompt me to please open the project associated with this file and try again. Okay, so it has not recognized where my code is because I just created it. So I will save it. I will close it. I don't want to save my workspace image. You're going to see a picture of my sister from a long time ago. You're going to see that picture for a second. This is where my code is. So here I've opened it again. Okay. And now it should work. Let me load the packages again. Zoom out just a little bit. And then there we go. Now I've run this. And you can see it's printed out a sentence to say here starts at users, my name, and then desktop. So what this has done, I call it anchoring my code because it's almost as if it's like dropped an anchor where this coding document lives. And now anything I import will be relative to this. So if I import data, it's going to look for that data in my desktop file. So I have to make sure that whatever data I am importing also lives in this desktop file. If it lives within a particular folder, I'll have to tell it to first look for the folder and then look for the data. That's usually a clean way to kind of anchor your code and make sure that anything you are importing is relative to where your code lives. So now I will load my data. I'm going to be really simple and I will call my data data. And now I'll use the function import from Rio. And I will put in quotation marks over here. A cool trick is if you just press the tab button. So I'm pressing tab, and now it has pulled up all of the files on my desktop. So over here, my thing is called HIV data 2. So if you press tab, you should get something pop up, and you can pick within that. Ludovic is asking, is anchoring like setting a working directory? Yes. So setting a working directory, if you manually specify a working directory, it's usually not good practice because you can see this won't exist. For example, user/ashnopal/desktop, that file path is not going to exist on Duncan's laptop, right? That's a file path that's unique to my laptop. So if I were to manually set the working directory with set wd and then put in that file path, it would work. The code would still work on my laptop, but as soon as I share this code now with Duncan, it's not going to work for him. So this here I am kind of sets your working directory in a way where it's now relative to whatever machine I'm using, if that makes sense. So you can see in my actual code, there's no place where I mention my name, or there's no place where I mention a file that only exists on my computer. It's an intelligent function that'll recognize where on my computer this code lives, and it'll set the working directory based on that. So yes, it is like setting a working directory. And then here I can import my data. And you can see as soon as I ran that, it has now appeared in my environment pane up here. If I click on it, it should appear like this. So you can see it looks exactly how it looked in the Excel sheet. I'll go ahead and close it over there. So the next step, this is what I like to call the data snapshot step. This is what this function called skim, or this package called skimr is quite useful for. So if I say skim data, it's going to print out a pretty chunky looking thing. But this is what's actually going to help me clean my data. Okay, so you can see it's printed out something called a data summary. It's told me how many patients I have. So I have 1,500 patients. I have 6 pieces of information for each of those patients. And that will tell me column types. So if you remember from the first or second module, we talked about column types, right? We talked about characters, dates, numbers, and the fact that it's important to know data types because you can only do certain operations with certain data types. So I can see already that there's one column that has characters, but then the rest are numbers. That's informative. Now it's going to tell me by column type, it'll give me a quick summary. So there's one column that's type is character. Column's name is gender of patient. So over here, it's telling me it has n unique is the number of unique values. It's telling me it has 3 unique values. If I remember data, when I opened data, gender of patient is numeric, right? It's 1 and 2s. So there's a 3rd value over there. That's a little bit suspicious. And also, if it's a 1 and 2, why is it a character? So I put a little note in my head to say, we'll check out gender of patient after, because it's likely that there's something unexpected there. Now, what else do we see? So gender, I've got a little asterisk. I can put in my notebook to say, come back to gender, see why there are 3 unique things. Of course, there are many genders out there, but in this particular data set, there should only be numbers 1 and 2. So I'll investigate that after. And then there's 5 numeric columns over here. You can see there's patient ID over there, mean 750, standard deviation, it's okay. Age, mean 42, standard deviation 34, that looks okay. HIV status also looks okay. The rest of these look okay. There's one in age, hold on. So there's one in age, okay, so it's a little bit spread out over here. So age is the 2nd row over here, and the 2nd row. Can somebody tell me what looks weird in age? You can type it in the chat or raise your hand. What seems to be a little bit off about age? There is one person in this data set who is 982 years old. That is a strange observation. So it's not something that's expected. So that's also a flag over here. So you had one flag with gender of patient and one flag with age. The rest of these kind of seem as expected, and this is where it's quite good. I mean, you are medical students, so this is something that you have the clinical context for, but often, so people like me, I do not have a medical degree, so a lot of these numbers, I might not be able to catch if something looks weird, but it's always good to have that medical background, and if you don't, work with somebody who has a medical background who might actually tell you, like, for example, if there was some odd value for viral load, they would be able to recognize it. They'd say, oh, this is unexpected. You should investigate, and then clean that up in the data set. Here, the only odd value to me was age, because the oldest person was 982 years old. So now we've made a note to fix that by, usually the way of fixing it is just removing it from the data set. But I'll pause there for a second. Does that make sense for how we just took a look at our data set? Is there anything from this output that looks bizarre to you? Okay. I'll take silence as an okay. Please do interrupt me if something seems off. So we have done so. Now we have completed the first few steps. We have created an informative header at the top. We have loaded our packages. We've anchored the code, loaded data, and finally we've taken a data snapshot just to see what it looks like and what we might have to fix. So over here, remember I said gender of patient, something's a little bit weird. happening here. So I might want to take a closer look at that. So if I say closer look, take a closer look at gender. There are several ways you might want to do that. One of my favorite ways is this. It's a little trick that people use. They say summary as factor. So factor just changes it into a categorical variable. Let me say data $ gender of patient. So what this is going to do is it's going to give me a quick snapshot of what that particular column looks like. So I can see, as expected, we have ones and twos, but there's one person where the actual value is TWO. So it's 2, but it's spelled out. So this is probably what was causing that entire column to appear as a character rather than a number. So now what I'm going to do is I'll make sure to go into the data set, fix this. And so gender can be treated. There's 2 categories instead of 3, because this one should actually be a part of this. So now that I've taken a closer look at gender, now that I've looked at the data, now I can actually start cleaning. So the first steps I like to do when cleaning the data, you can see there are some column headings where, like gender of patient and HIV status, the column heading is actually a little bit complicated. I mean, it's not that long, but there are spaces in the column heading. Spaces sometimes confuse R for whatever reason. It's R likes to have underscores or dashes or periods or something within the sentence instead of spaces. So what we're going to do is we're going to use this little trick called clean underscore names. And we'll see exactly how that works. So if I create a data set called, I'll just call it data clean, and I'll use this assignment operator to say, dig into my data, pipe operator, and from the janitor package, I'll say clean names. That's it. Just that. And I'll say clean names. So very, very simply. So I ran that. No issues. And I can see it on in my environment up here. Now I have 2 data sets. One's the original data and one's data clean. Now the reason I could have quite easily just overwrote that same data set. If I just kept this as data, what it would have done is it would have taken the original data set and wrote over it. I'm purposely creating a new one called data clean because we're going to go through a lot of data cleaning steps. And sometimes if those steps, the code messes up or doesn't work as you would like to, you always have kind of this raw data at the beginning that you can go back to. So it's kind of just makes your life a little bit easier if you create a new data set. We can see in data clean what has happened here. So now what it has done is it has introduced a little underscore in each. So what clean underscore names, this function right here that we ran, what this does is it'll go through each of the column headings in the data set. If there's columns that have multiple words, it'll put an underscore in between those words. As well, by default, what it does is it changes everything to lowercase. I think this is just for simplicity. So you can see columns like CD4 and BL, they're now lowercase. It might be just for cleanliness. It does that, but that's kind of what I like to do as a first step. You do not have to do this, but it's something that I like to do because there's quite a few. Like for example, there was one data set that I was working with that was based on a survey. So actually each of the column names was the entire survey question. And you can imagine that gets very long and very messy. So this clean names made it quite easy to work with, but actually I can even shorten column names by using the function called rename. So I can say, actually, I don't want a long name. I'll just say gender of patient, and HIV status should just be HIV. Very simple. So now you can notice I'm adding on steps. I'm not creating a new line of code or a new chunk of code. I'm joining this step to the previous step with this pipe operator. Now, if I run this and check data clean, Now you can see it's changed the column names. Now it's just gender and HIV. So now I'm going to play with the two, so gender and age were the two columns where something strange was happening. So I'm going to change some of those values. I'll say fix odd values in gender and age. And you notice each step I'm doing, I'm adding a little line to explain exactly what's happening. That's just good practice for whenever you're writing code, because chances are I will return to this in a few months from now and have no idea what's happening. And then if I have comments, it always just helps figure out what's going on. So would definitely encourage commenting. So if I say fix odd values in gender and age, I'm going to use the mutate function over here. There are several ways to do this. I know Frank introduced recode in the previous section. I like to use case one, but you can use recode. There's also other ways. I think you can have if-else statements. Other people can recommend other ways as well. But how I like to do it is, for example, with gender, I like to say gender case underscore when. So I said when the weird value for gender was 2, right? So if I run this, I can confirm. Where are we? Take a closer look at gender. Yep, it was this 2. I want to say in case when gender is 2, I want it to actually be 2. Comme ça. I want it to just be 2 like that. And then otherwise, I don't want it to change. So I say default equals gender. So this is a way to say, I'm looking at the gender column. I'm saying case when, which basically means when gender is equal to 2. So when gender is equal to 2, spelled out, I actually want to replace that value with the number 2. And you can see I've put it in brackets or in quotations. I've done that on purpose because if you remember from our skim R over here, gender of patient was actually a character variable. So it wasn't a number, it's a character, meaning that it's text. So it requires these quotations around it. So I want to replace 2 with the number 2 and say, by default, I want it to just be equal to gender. So I don't want any other value to change. So if I run that now, it should have worked. So now in theory, if I run this again, where are we? Summary as factor. Oh, I don't want this to be data. I want it to be data clean, right? Oh, something strange has happened. Let's see what's up. Oh, it's because gender of patient doesn't exist. We'll say summary of as factor. It's just called gender now. There we go. So you can see now it just has 2 values because I've recoded that character 2 over here. But gender is still a character, right? It's not a number. For now, that's okay. We're not going to do any numeric operations with it. For example, we're not going to say gender times 2 or gender divided by 3 because that wouldn't make sense. But if ever you needed to change it into a number, you'd have to make sure to first change it from character type to numeric type before actually using it. But for this purpose, it doesn't matter. So I'm going to leave it as a character for now, and then we can come back and change it if we need to. So there I fixed gender. Let me also do age. So with age, I can just do a column or a comma, sorry, and say, now we're going to say age. Or actually, for cleanliness, I will start a new mutate. I'll say age. And with the exact same way, so age, what was that weird value? I think it was 982. Yep, over here, 982. So I say when age is 982, I'm going to replace it with a blank. But R is strange in that it will not let me replace it with just any old blank. I have to say any integer. because age is that column is a number column. So this will replace it with a blank, but some remix of a blank value where it actually replaces. It's nuanced, but you can just say NA integer to replace it with a blank value. And then we can say, like before, default equals age. And again, as I said, there are other ways to do this. I like using case one because it kind of reads like a sentence to me. So I say kind of when the case is that age is 982, replace it with a blank value, and then otherwise by default, keep it like age. But if you like to use recode, like Frank was using last time, please use recode. Use whatever works for you. So now, I've run that. In theory, now if I say max data clean age, it should not be 982. Oh, now I've introduced a blank, so I have to say NA, remove NAs is 84. Okay, cool. That's a reasonable maximum age now. So we don't have any more 982-year-olds in our data set. So here, once I've fixed odd values, and this is a simple case, right? This is made up data. We only have 2 odd values to fix, but often in your data set, you have many, many odd values to fix. So this is why data cleaning ends up being like more than 80% of the job, is because you end up having many strange values that you kind of have to pick. And you notice that over here, one way I could have done this is if I had opened my Excel sheet, if I had opened the actual data, one way you can do this is actually manipulate the data set itself. That's usually bad practice because the raw data should usually just stay as it is, even if it's super messy, even if there are mistakes like this 982-year-old. Don't manipulate the actual data. That's what R is for. You import the raw data and manipulate everything there. And then what is the Excel sheet is usually left untouched. Or for example, if you have data that you're pulling from some online repository that you usually can't change anyways. So you usually kind of leave this as is, even though it would be easy to kind of just go into the Excel sheet and change it myself. It's good practice to do everything kind of in your analysis pipeline. Okay, so now that we have fixed odd values in gender and age, and we said, okay, there's nothing else that was looking weird to us, we're going to move on to the next step. And we're going to make some things a little bit more intuitive. This is something that I will repeat from what Frank did previous session. So if you remember, he had recoded gender and HIV to equal, so instead of 1s and 2s, he gave them actual labels. So HIV positive, HIV negative, male, female. He was renaming it or recoding it like that. And again, recode gender and HIV. Again, you can use recode. I'll use case one. You can use recode. Both work. Let's say case one gender. Oop. Hold on. Case one. So when it equals 1, I think 1 is female. And then when it equals 2, it should be male. And then similarly, I'll mutate HIV. Case when, oh, I've already made a mistake. And somebody might have caught my mistake. Gender is not a numeric variable, so it's going to look for text. So I have to make sure to put my numbers in quotation marks like that, because otherwise it'll be like, oh, 1 and 2 don't exist because it's looking for numbers, but now that I've put quotation marks around it, it'll look for the actual text. HIV, on the other hand, was a numeric variable, so I can leave it like this, negative, And when HIV equals 1, positive. Cool. So now, actually, I'm going to make new gender coded, and I'll say HIV coded. Here I'm creating 2 new variables, just so you can see how the recoding happens. If I run this in my data clean, you can see now I have, you can even see it in the environment. Data clean now has 8 variables instead of 6 because I just added 2 new ones. Gender coded is female. So as we said, when gender equals 1, it's female. When gender equals 2, male. And HIV coded, when it's 0, it's coded as negative. And then when it's 1, it's coded as positive. So here I've added 2 new variables, gender coded and HIV coded. Okay. So here now I have, so these, by the way, so this data cleaning, I'm trying to go through sort of common steps that you might do in working with your own health data. So cleaning names, shortening column names. This is a pretty common step that you do in data analysis. Fixing odd values is typically the next step that you do. Recoding is then typically the next step that you do. And another common step that you do, as Frank touched on last time, is creating new columns. So I'm going to create new column for age category. I believe last week he used a really, really handy function actually called categorize or age categories, which is very nice because you can actually specify the breaks. Again, if you want to use case 1, I'm trying to hammer home how useful this statement is. It's actually one of the big workhorses of data cleaning, because it allows you to kind of see how the variable that you're working with, how that's mapping onto this new category. So if I create a new column for age category, so I can see, if I remember from previous steps, I think the biggest age was 84. I say when age is less than 10, I'm going to call it 0 to 9. Age is less than 20, 10 to 19. So here what I'm doing, you might be saying, why am I saying always age is less than? Because I could quite easily also say when age is bigger or equal to 21 and less than 30. This would also be correct, but I don't really need to do all of this because automatically if age is bigger or equal to 21, it'll kind of automatically end up in this 3rd line here, if that makes sense. So I don't need to be that specific. We can kind of do this quite quickly then. 30, 40, 50, 60, 70, 80, and then age bigger equal to 80. We're going to call this 80 plus. And now I'll go ahead, 60, 70. Okay, hopefully that makes sense. Here I've created a new column called age category, and it depends on age. So it's telling me when age is less than 10. I'm going to call this age category 0 to 9, and then kind of based on the next conditions, it creates new age categories. Then again, if I run this, you'll hopefully be able to see how it works. So you can see age category is this rightmost column here. You see this person is between 40 to 49. This person is 20 to 29. I always like to go back to the data set and just make sure that what I have coded actually makes sense. This 83-year-old is an 80 plus. Great. So I'm just doing some spot checks to make sure this makes sense. And now you can see this person does not have an age, so they do not have an age category. Nice. Okie doke. Now kind of we have, so that's usually kind of the last data cleaning step you do. There are, of course, this is a very simplistic data cleaning pipeline. Each of these steps usually takes very, very long, and you usually don't just create one new column, you usually create several new columns that you want to work with. Your data is often a lot messier. So this is kind of what typical data cleaning step might look like. And now you have a data set that you can actually work with and use to create tables and figures. Before I move on to the next step, I'll just pause there to see if anybody has any questions.
Maybe I can ask on their behalf.
Sure, yes.
There's that line 26. Line 26,
Yes.
when you're doing the factor for the gender, what will happen if I don't use the single quotation marks in that gender
Over here.
end of
Let's
page?
see. This one. So here it's going to tell me unexpected symbol because R doesn't like spaces in column names, so it won't actually be able to find gender of patient.
Okay. So that's that may be the motivation to actually clean the names so that it can put the underscores for you in the spaces.
Yeah, that's a really good point, actually. Thank you. Yeah, this is motivation to clean the names, just so R doesn't get confused.
Okay, thanks, Ashna.
Thank you. Okay, there's no other questions. I'm going to pivot back to the PowerPoint over here. And then just show the next slide. So now what we're going to do, now that we have a data set that's kind of clean and ready to go, we're going to try to answer two questions. They're both very, very similar, just asking for different information. The first question is, of those that are HIV positive, what is the median and interquartile range for CD4 count and viral load by age category? That's a mouthful, but that's a relevant question that you might wish to use this data set to answer. So I'm going to copy it. Summarize data. So our next step. Here, and I'm going to wrap this text over here. So our first question is, of those that are HIV positive, what is the median and interquartile range for CD4 count and viral load by age category? So over here, it's very easy to get super overwhelmed by this question because it's asking so many things, but we can kind of break it down into steps. So what it wants us to do, the first thing it wants us to do is of those that are HIV positive. So it would like us to only focus on HIV positives, and then it wants us to pull out two values, median, interquartile range, for two different variables, CD4 count and viral load, and it wants to know what these two values are by age category. So we can kind of take this step by step. So I'll be working with my data set, data clean, right? Because that's a data set that's kind of clean and ready to go. I'm going to use my pipe operator, and I'll do the first thing. The first thing is of those that are HIV positive. Pull out, or not pull out, I'll say focus on HIV positive only. So tidyverse has this really, really handy function called filter. So I'm going to say HIV, filter HIV coded equals positive, right? So when I do this, if I run it, it's just going to print out in the console. So maybe I'm just going to create an interim data set just so I can show you what it looks like. So now you can see this is a data set where HIV coded is positive. We're now working with a subset of data for just HIV positive patients. Okay. What's the next step? So next step, it wants to know median and interquartile range for these guys, but it wants to know it by age category. So I'm going to work backwards a little bit. I'm going to group my data So tidyverse also group by age category. So tidyverse has this really handy function called group by. And what this does is that it ensures that whatever follows, if I say group by age, so if I group by age category, what this is going to do is it'll make sure that anything I do, any operation that I perform from here on out is grouped by age category. So it'll perform individual operations based on age category. So if I want to count how many people are per age category, it'll simply do that. But kind of makes sure that it's almost subsections the data. And it says now whatever I calculate will be calculated for each of those sections. Very handy function that way. So we've already kind of tackled. We've already tackled this. We've tackled this. And now I need to focus what's on the middle of the sentence. What is the median and interquartile range for CD4 count and viral load? What I will do is now, because I only really care about CD4 count and viral load, I'm going to select those variables. Select variables of interest. I'm going to say select CD4 VL. So now if I run this, adding missing grouping variable. Oh yeah, fair. It'll need age category. I almost forgot because we want to summarize by age category. So select age category, CD4 and VL. There we go. So now you can see it's still 143 observations, if you remember, because we only focused on those who were HIV positive. So now select variables of interest. And now I summarize median and I'll just call it IQR, interquartile range. And how do I summarize? I use a really handy function called summarize. So I'll say median value. That's just the name of the column that I'm giving it. I'll say median value will be median CD4 or median CD. Let's say median CD4 is median CD4. IQR CD4. So this is an IQR function that pulls out the interquartile range. And then median BL, IQR BL equals. So what this is doing is creating, there's another way to do this as well. I'm showing you one way right now. So it's creating a column for medians, IQRs for CD4. It's calculating it for each one. So for CD4, I'm calculating median and interquartile range, and then for viral load, median and interquartile range. So now I'm going to run this. I'm going to remove this so I can actually just print it out and show you. Oh, there's no function called IQR. Let us check. Calculate IQR in R. There's an IQR function. Oh, but it's in some package called env stats. That means we need to load another. So I want to add it to my, oh, okay. So here I've added it to my load package step. So hopefully that'll work now. There you go. So now what it has printed out is, so we've got a column called age category. And it's printed out median CD4 count, interquartile range for CD4 count, median viral load, and interquartile range for viral load. And it's done that for each age category. This is focusing only on, because we filtered by HIV positive. So now it is focused only on patients who are HIV positive. So now you've got a summary of your data, and this is informative as well. So if you remember last time, Frank was asking, kind of which age categories seem to have the highest versus lowest CD4 count. And same things, this allows you to see which age categories have the highest versus lowest viral load. So that becomes informative there. Are there any questions about how we answered this? I'll pause for a second. No questions? Okay. In that case, we're going to practice this one more time with the next question. So the next question is asking, of those that are HIV positive, what is the mean and standard deviation for CD4 count and viral load by gender? So now you can see this is also asking a very, very similar question to the previous one, but it's asking for slightly different information. Let's see. Now, of those that are HIV positive, what is the mean and standard deviation for CD4 and viral load by gender? So now I'm going to ask you guys, what should be, I'll put in data clean. What's the first step here? Can someone answer for me in the chat? What's the first step should I do? You can also raise your hand if you want to jump in. We'll call out names. Ludovic, what's the first step I should do? Oh, Ludovic said lost the code along the way, still wondering. So over here, so if you remember in the previous one, and you can just say it in words, you don't have to remember the actual code. We focused on the first part of the sentence. So of those that are HIV positive. So what should the first step be? So I can scroll up. This one we said, of those that are HIV positive, and our first step was to just focus on HIV positive only. Yeah, here. Oh yeah, I see Kioma has also said, make an interim data set. You can if you want. That was just me showing you, just to show you what it looks like. You don't have to make an interim data set if you don't want to. That was just for me to show you. But the first step is usually, if the question is asking you to focus on one particular group of people, you will say you can filter it to focus on that particular group of people. So of those that are HIV positive, so here I'm focusing on HIV positive only. Then what happens next? So next I have, it's asking me, what is the mean and standard deviation for CD4 count and viral load by gender? So over here, if I say group by, what am I grouping by? Oh yes, Ludovic is correct. Filter HIV positives and categorize by what they want. So what we want over here is gender. Group by gender. Nice. Group by gender. And then select variables of interest. I'm going to select, what variables am I interested in? There should be 3 variables I'm interested in. You can type them in the chat. So what are the 3 variables I should put here? In the previous question I had, oh yeah, she almost got it. Instead of gender, mean, and standard deviation, because mean and standard deviation aren't actually in my data set, here I'm selecting variables of interest. So in the previous one, my variables of interest are age category, CD4 count, and viral load. So over here, what do we think my 3 variables of interest are? Gender is definitely one of them. Then what are the other 2? I see, yeah, CD4, VL. Nice. So now I've filtered to focus only on HIV positives. I've grouped by gender. I've selected my variables of interest. And finally, I'm going to summarize. Now, what do I want? The person who is asking me this question wants mean and standard deviation. So I'm going to create one column. I'll just call it mean, CD4. And I will take the mean of CD4 count. SD, CD4, I'll say SD, CD4 is, oh, no worries, Chioma. It is a little bit confusing. So here, now I'm going to say mean of viral load, it's mean VL, and then standard deviation of viral load equals SDVL. And again, what I've got over here, I can make these more informative. Mean, I can make these sort of prettier. Standard dev. This just to show you can make them sort of better column names or more informative column names if you want. Viral load, standard dev of viral load. So here now, if I run this, there we go. Oh, hold on. I can see gender is 1 and 2, but I forgot we have a variable called gender coded. That is a more informative variable. If I run this now, there we go. So gender coded, you can see mean CD4 count, generally higher among females and males than mean of viral load, also generally higher among males versus females. You can see over here, one more variable. The variable names are a little bit long, so maybe I will go back to having simple mean CD4, SD, CD4, mean EL, SD, EL. There we go. Now we have a simple table. Does that kind of make sense? That's a step-by-step process. So we filter. So Chioma is asking, so you don't need to create a smaller data set to summarize data in the bigger data set. Not necessarily, like over here, I haven't actually created any data set. So you can see that this is me just printing out data clean over here. I could create a smaller data set if I wanted. Like for example, if I had several questions that are only asking me to focus on HIV positives, I might want to first create a separate data set just called data_HIV pos. And then what that would do is that would eliminate this step over here, right? Because you can see in both of these questions, I kind of did the exact same thing twice. I focused on HIV positives, but if I wanted to first create an HIV pos data set, I could say data HIV equals data clean. And I could do this only once, focus on HIV positive only. Here, so if I said data HIV, now you can see in my environment, you can see that I have data HIV over here, which is now focused only on the HIV positives. Now I can remove this instead of data clean. Now I'm looking at data HIV. I can remove this step altogether because I don't need it anymore. And then similarly here, I'm looking at data HIV, and I can remove this step altogether. So you can create a smaller data set and just work with that. All that'll do is that'll save you that filtering step. So now if I run this, it'll be the same thing. Hope that answers your question. Are there any other questions before we move to the next thing? No worries if not. What we'll do after is I will pass this along to Mary J and team so that this script can be uploaded to Afredac along with the data set that it requires, and then I encourage you to kind of play around with it. What you've seen here, this is kind of a typical, it's not a long code, so we just wrote about a little over 100 lines of code, but this, the intention of this was to show you the typical step-by-step process or analysis pipeline, if you will, kind of what the typical steps are. Different data scientists code differently, but this is kind of what all of my codes look like. Like if I open up a recent analysis, you can see it kind of follows the exact same thing where I load my packages, I anchor code, I import data, then I clean data, rename columns. So all of this kind of, and you can see here, this data set is a real data set. So it's got messier data, and there's quite a few things that we've had to fix in it. But this kind of shows you real world data cleaning and what it typically looks like. So definitely give yourselves a pat on the back, because this is only what, class 6 or 7, and you're already at this stage. So you're basically a data scientist now, because this is most of what we do is exactly this. So I just wanted to show you that. And in the last sort of 20 minutes that we have together, I will quickly introduce the last step, or well, one of the last steps of this analysis pipeline, if you remember, which is data visualization. We already created a couple of summary tables by answering those questions. In the next few sessions, we'll actually see how to make prettier tables. There are really, really handy functions that make very pretty tables, and ones that do it quite fast. We'll also see how to do some basic statistics in R, and we'll get a deeper dive into data visualization, but I wanted to introduce it today as sort of the next step in the analysis pipeline, because these tables that we created, this is a simple table, but you can imagine bigger tables, like even the one we made before. Something like this, it's not kind of obvious. You need to look at it in closer details to actually understand patterns from it, but graphs are a lot easier to get a quick idea of what your data looks like. That's what I mean by data visualization. So I'll show a quick, I just have one slide here that'll quickly introduce data visualization. Next time we'll focus on it more. Duncan's kind of a data visualization expert, actually, so he will likely go into, him or Frank will go into more detail about this, but the workhorse function for data visualization is something called ggplot, and I've included this link over here. ggplot2 is the package that exists within the tidyverse package. A ggplot, so GG means grammar of graphics. This is the workhorse function. Kind of usually when you're making a plot in R, you are using the ggplot function to make it. And the same way we learned about tidyverse working in layers, meaning tidyverse works kind of step by step, ggplot actually also works step by step. So what you see here on the left side of this slide is different layers that exist in ggplot. And you can think about this bottom up. So you have your data layer, then you kind of focus within that data. What exactly are you plotting on the x-axis, on the y-axis? Then you have something called layers. So it'll ask you, are you making a bar plot, a scatter plot, line graph? And you can have more than one based on what you want to visualize. And then you have the rest of these. So the rest of these we won't focus too much on right now. Let's just focus on the bottom three layers. Data, mapping, and then layers. So bar plot, line graph, scatter plot. I'm going to open up this link actually to show you what this looks like. This link is Introduction to ggplot2. I'll put it in here as well so that everyone can check it out. I do encourage people to take a closer look at this, but don't worry about it too much because we'll get more into data visualization in the next session. The idea of today is just to give you an idea of what you can do with visualization. So over here, this link shows you, you can create something like this for your data. This is exactly what was on the slide. So I'll kind of go through the first three layers with you today, just to give you an idea. And then when we come back to it next time, it'll kind of be, hopefully be clearer with some examples next time. So the first layer is always the data. This function over here, ggplot. So first you always specify what data that you're using. So the data that we're using is our data clean. The data that this person is using is called MPG. So that's very, very simple. You always open up a plot by specifying what data you are using. Then is the mapping layer. So the mapping basically tells, so ggplot, you can see this person is using the data MPG. And the mapping layer tells the function what goes on the x-axis and what goes on the y-axis. AES just means aesthetics. So it's mapping the aesthetics. CTY, it's mapping to the x-axis. HWY, it's mapping to the y-axis. So that's all there is in mapping. It's just telling me what I need from my data set and where I'm putting it. But now I also need to know how I'm putting it. Am I putting it in a way where it appears as a graph or as a bar, as a line, as a dot? That's what's crucial to the layers function. So you can see over here, I'm gonna ignore this text for now, just jump down to the example. So this layer is called geom_point. So you can see this is the same as above. So ggplot, MPG. You can see they've kind of, they're skipping some labeling over here, but it would be equivalent if I added mapping equals AES down here. So I'm saying ggplot, the data is MPG. On the x-axis, I have CTY. On the y-axis, I have HWY, and then I'm adding a point. Geom_point is the layer that I'm adding here to tell it to add points to my data set or points to my graph. And then I'm adding another layer. So this example shows you that you can add multiple layers. And here I've created a scatter plot, and I've also added a trend line over here. This is just to show you a simple example. Don't worry again if you don't understand the basics. This is just to show you sort of the simple components of ggplot. And we can even try it with our own data set. Now I say visualize data. I'm going to use data clean. So I'll say data equals data clean. So all this does, even if I just run this, it's going to open up a blank plot. There's nothing on here right now. This is the blank graph. I'm going to say first is data. Then what do we say? And here, the interesting thing about ggplot, which makes it different from tidyverse, is instead of a pipe operator, now I just have a plus sign. Now I just have a plus sign. But actually, my second data, the second one is mapping to mapping. Here, I'm just putting on separate lines, so it's a little bit cleaner, cleaner for reading. So data mapping, what do we say? Mapping AES. What do we want on our x-axis? Let's think about what to plot actually. What would be an interesting plot? If anyone has any ideas, please pop them in the chat. Otherwise, I will just think for a moment. Perhaps we can plot on the x-axis, maybe we can put age category. And then we can plot on the y-axis. Maybe we can have a bar chart for sort of negatives versus positives for HIV status. Let's see if we can make that. So here, if I say X equals age category, and then Y equals HIV coded. If I run this, still nothing is going to appear on my chart, because now you can see it has the data, right? The data clean, and it has the mapping. So it knows exactly what I want. Here, I'm going to zoom into this actually, so it's easier to see. Where are we? Ignore this NA for now. We can learn next session kind of how to ignore that. But you can see over here, now that I've supplied it 2 pieces of information, right? I've supplied it the data set, and I've told it supplied mapping, right? So with mapping, it knows what to put on the x-axis and what to put on the y-axis, right? It knows age categories on the x, and it knows HIV status is on the y-axis. But you can see nothing's actually on my graph yet, right? Because I haven't told it the third step, which is layers. So I haven't told it actually what I want my data to look like. So I'm going to put a plus here. And the third thing we do is layers. So let's say I want it to equal, third is layers. That's what's happening here. So I put a plus sign, and then let's see geom bar. Let's see if it'll, I don't actually know what this will look like. Nope, it doesn't like bar. Geom point. Okay. So this makes no sense right now, but just to show you, just to illustrate my point, pun intended, is that now you can see there's information on this graph because I have actually asked it to plot layers. So I've said geom point. Obviously, this is not informative right now because it just tells me that there's people in this age category that are negative and positive. That I already knew. So that's not informative, but just to show you that now that I've said geom point, it has plotted things on this graph over here. And you can kind of change what it looks like. So if I said, if on the y-axis, so instead of HIV coded, let's see if I have some continuous variable. Maybe not. If I said geom call instead, would it like that? What if I said geom calls? Now it's got number of people over here. You can even do things like separate column color by HIV status. Oops. Bill equals HIV coded. Something like that. So it kind of tells me how many people are negative and positive in each age category. Yeah, this, don't worry too much about the details now, but I just wanted to show you kind of how you can customize ggplots like this. And we will learn more about this next time, but in the meantime, I do encourage you to check out this website that I just shared. Kind of goes through, try to understand the first 3 sort of layers. So data, mapping, and layers, because this is kind of the workhorse. This is the main part of the ggplot function. And what's cool is that you can kind of see how it builds the plot step by step. So this part just creates a blank graph. This part will actually map to the X and Y axis. This fill bit just informed it informed the ggplot function how it wants to color the different bars. and the layer proceeds to tell R exactly what I want to plot. If I want to plot points, bars, lines, that sort of thing. This is sort of a simple example. There's lots of other things you can do. So of these different sections, the first three kind of are the main ones, and then you can do things like scale, so you can change colors, you can change point sizes. Facets allow you to introduce different sections in your graph. You can actually flip the X and Y axis as needed. You can also change what the background looks like. For example, you can see this background right now is colored, right? It's got gray background. So if I put, for example, if I want a plain background and I put theme minimal, it now removes the gray from the background. So all of these just go to show that there are lots of ways you can customize your graphs, and basically anything that you think up that can be graphed, usually it can be customized and graphed with ggplot. So we will definitely dive in deeper next time. But this was just to give you a taste of what it actually looks like and kind of what the components of ggplot actually are. So I will pause there. And again, I will share the code and data set so that it can be uploaded. But are there any questions before we close? Thank you, everybody. Thanks for bearing with me today, and we'll see you guys next Thursday.